Okay, hello and welcome. We're going to go over this problem statement today. Find the last digit of the factorial of a given non-negative number n. We're going to use the UMPIRE method to figure out how to solve this problem. So the first step is to understand what's going on. So what do we have here? We have an input, which is n, a non-negative number. And then we have the output, which is the last digit of the factorial. And so we have a couple examples we can go over to see how this works. So if n equals 4, then we have 4 times 3 times 2 times 1, which equals 24. And then we just extract the last digit of that number, which is 4. And there we have it. So this is the input, and the output is 4. So if we have something like input is n equals 6 or something, we see that 6 times 5 times 4 times 3 times 2 times 1 has a factor of 5 times 2. So give us 5, 10 times a number, which is a decimal value of 0 as the end digit. Since we are is multiple. So we have the output here is going to be 0. So we can see there's a pattern here that's for n is less than 4. We can compute the factorial, record the digits, and for n is greater than or equal to 5, we can just return 0 since n is a factor. N has a factor of 10. Okay, so now that we understand this problem better, we can match this problem. So this match is to other factorial like problems and to problems where digits have some pattern and pattern outputs have some pattern, and you can output pattern. And so what do we need here? We need selection statements. Statements for each n equals is less than 4, and else for n is greater than or equal to 5. And we don't need a for. Okay, so how do we plan for this? We are just going to record a dictionary of the last element of the factorial for n is less than 4, and then And then for n is, and select for n is less than 4, the dictionary element. And 0 otherwise. Okay, so now we can implement this. So how do we implement? So we're going to just have an integer n. So an integer n, I'm just going to set it to be 10 for now. Then we have a dictionary of the values of the last digit for n is less than 4, so 0. The 0 factorial is 1. 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. And 4 factorial is 24, so that's going to be 4. So this records the last digit of factorials for 0 through 4. And then you can write an if-else statement. If n equals 0, then print dic 0. If n is equal to 1, then print dic 1. N is equal to 2, then print dic 2. If n is equal to 3, then print dic 3. N is equal to 4. Then we want to print 4. And elif, and then else print 0. So that should have it. So that's the implementation of this problem. We can now review this problem. So we're going to visualize this in Python Tutor. So we step through this process. We first have an input of 10, and then we input the dictionary. And then for the different selection statements, we skip each of them until we find that that none of them are satisfied, so else 0 is printed. And so yeah, so we have the solution is 0, so we have a correct answer. So we can also check. Let's see if we go back to the first. I guess we can't check. So that's a check for 10. I guess we could go back. Let's just. Okay, we save this. We can also type in 3 or something. And we can check what's the review for that is. And then we just go through the motions. You save the dictionary, and when the selection statement hits 3, then the dictionary 3 is printed, and we have 6. So that's a review of the problem. Now we can go back and we can evaluate this solution. So if we evaluate the solution, we can see that the time space complexity is O(n) or is O1 because we're using constant space. We're just saving a dictionary of 4 elements, and so it doesn't depend on n. If n is large, we still are saving only a dictionary of 4 elements. And then the time complexity is going to be O1 as well, since if we select any. So if n grows, we are still selecting in a finite number of steps here. So we have O1 time complexity. So that wraps it up. Thanks for listening.